Section 1.7, Math 110. This section, first we want to talk about inequality. And one of the main differences between inequality and equation is that when you have equations like x plus 2 equal to 3, there is only one answer. There is only one number that when you add to 2, the result is 3. And that number is x equal 1 when you check. But in equality, if you have x plus 2 less than or equal to 3, that means find a number that when you add 2 to that number, the outcome is less than 3. So there are always more than one number. So here, when you find that value, all the numbers are less than 1. So if you want to list all these numbers, all the numbers less than 1, including 1 itself, is 1, 0, -1, -2, -3, goes all the way to -infinity. So you notice there are so many numbers. For that reason, we use the number line. Number line is straight line that is divided into equal sections and start from 0, and when your numbers go to the right, they all increase, like 1, 2, 3, 4, and when you go to the left, they all decrease. So to show something like that, you find a 1, label the 1, and when there is an equality sign, use the bracket, and all the numbers less than 1s are listed here. So there are so many numbers. You know, they are 0, -1, -2, -3, -4, goes all the way to -infinity. So in algebra, when in inequality, when we are using less than equal, we use a bracket. But let's say in this problem, we have something like this. X less than 1. It doesn't have equality sign. In that case, you put a parenthesis instead of equal sign. Okay. What x is like greater than 3? No, with no equal sign. So you label on the number line, you find 3, you put a parenthesis, and is all the numbers greater than 3, like 4, 5, all the way go to infinity? So you just do it like that. Or if you have x greater than equal to 3, then you use the bracket. Okay. So now here, like here, 2x is less than 14. So what we do is, you always want to find x by itself. You want to isolate x. So we divide both sides by 2. X is less than 7. All the numbers less than 7, that's how you graph it. See, they all are 7. 7 is not included because it doesn't have equality sign. That's why we are using parentheses. So not 7, but a number less than 7, it could be 6.99, but not the 7. So in that case, all the numbers less than 7, if you want to talk about the whole number, is 6, 5, 4, 3, 2, 1, 0, -1, all the way to minus. That's how you should by graphing. And this is how to do the algebra. One thing you need to remember is when you do the inequality and you multiply by negative, you got to switch the sign. Like here, you know, I need to divide both sides by negative because you want to find x by itself. And you don't want a negative x. You always want 1x, positive 1x. Remember, not even minus. So in that case, I divide both sides. You divide both sides by a coefficient of x. Numbers sitting next to x, you always pay attention to that. Divide both sides to that number. But we got to remember that inequality sign must change from greater to less. Okay? Think of this. Like on the number line, let's say example. Let's say on the number line, you understand that if you have like a -3 here and +5, obviously +5 is greater than -3 because this is a negative number, right? So -3 is less than 5. And of course, this is a symbol we use for less than, right? What if I multiply both sides? Multiply both sides by like -2. What happens if I multiply both sides by -2? -2 times -3 is 6. And what is -2 times 5? -10. Isn't it? Is 6, which is a positive number, less than -10? No. That's why you have to switch the sign. So when you divide, instead of writing 6 less, you just say 6 is greater than minus 10. Okay, so anytime you multiply or divide by a negative sign, you must switch the sign. You must switch inequality sign. So all we do here is just add 5 to both sides. And x is greater than 12. Greater than equal to 12 means goes all the way from 12 to infinity. See that? Why you're using bracket? Because it has also equality sign. Now, I show you 2 ways to do these problems. Okay? One is, if I want to always collect all the x's on this side, then I'll just say I have 3x and 5x. So I move 5x to that side. To move positive 5x to the left side, you're going to put minus 5x here and minus 5x there. And obviously, you need to move positive 9 to the other side. So you add negative 9 to both sides. So in that case, I end up having a negative 2x less than minus 4. And since I want to have just x by itself, not even negative, divide both sides by negative. When you do that, x is 2, but remember, you must switch the inequality sign. It cannot stay less anymore. It has to be greater. Now, is there any other way to find the way not to worry about this part anymore? Yes. Before you start switching numbers or variables around, think of this. 5x, positive 5x is greater than 3x. So instead of bringing 5x to this side, why don't you move 3x to that side? Because this is larger. You always move it to the side which is larger. So in that case, if I want to move 3x to this side, I put a minus 3x and minus 3x. And obviously, I want to take numbers to the other side. You do that. So in that case, you do not end up with a negative. You don't have to divide or multiply by negative, okay? You just remember at the end, you come up with this answer, 2 less than x. What does that mean, 2 less than x? It means x is greater than 2. It's like, yeah, let's say there are 2 numbers. Mike is shorter than Tom. Mike is shorter than Tom. Doesn't that mean that Tom is taller than Mike? Yes, that's what happened. 2 is less than x. Like if x is 5, 2 is less than 5, or 5 or x is greater than 2, okay? So this is a better method to use. Means from now on in equality, when you want to switch all the variables on one side to the other side to see which one has a larger x and move the shorter one to that side. In that case, when you end up having situations like this, you don't have to divide by negative anymore. You divide by positive, so you don't have to worry about switching the inequality sign. You just remember at the end how to graph that. See, like in this one, I have 3x and negative 4x. Obviously, negative 4 is less than positive 3, so I move minus 4x to that side. Anytime you're switching from one side to the other side, all you need to do is change the sign. You know, rather, there are 2 ways to do it. You know, when you do it like this, if I want to move minus 4x to this side, I can either do it this way. I put a 4x here and positive 4x, right? Which make it 7x. Or just remember that anytime you're taking a variable or a number from one side to the other side, all you need to do is switch the sign. Like minus 4x, if you want to move it from right to left, you become positive 4x. This negative 1, you want to switch it from this side to the other side, become positive. Okay? So in that case, I'm not dealing with dividing or multiplying by negative signs. So x is greater than 2 over 7. Now, when you want to graph it, if you're not sure what is 2 over 7 because it's a fraction, just divide it. X is greater than 0.3. All the numbers greater than 0.3, which is somewhere here. You see that? This is 0.5. So pick a point here near to 0. That's 0.3. And then all the numbers to the right. Why is it bracket? Because it has an equality sign. Okay. So when you deal with a fraction at the end, you could always change it to decimal. That will help you to understand what you should label that point here. So what I need to do is first I need to distribute 7. And then is minus 6 greater than minus 7? Yes, look at the number line. Minus 7 is here and minus 6 is there. Obviously, minus 7 is smaller than minus 6. So in that case, I move minus 7x to this side. See? That would make it positive, and I move 9 to the other side. See, in that case, I don't end up having a negative. So x is less than 5. All the numbers from 5 to the left. This is a type of inequality that they combine two inequalities, is a composite inequalities, okay? So what you do is here, when you are adding or subtracting, you do it to both. For instance, let's say I don't have this part. All I have is this, 3x plus 4 less than, how do you solve 3x plus 4 less than 13? First, you need to move 4 to the other side, right? So you gotta put negative 4 here. When you're dealing with a composite, when you put negative 4, they'll put a negative 4 everywhere, all three of them. So you do all together. So in that case, you have what? You have 9, 3, negative 3. Divide everything by 3 because you always want to find x itself. This means x is one end is 3, one end is negative 1. X is bounded between these 2 points. That's why you have a parenthesis. X is always less than 3 and greater than minus 1. So this is the sections when you graph it. X is between these 2 numbers. Very similar. So what we need to do is first we need to distribute 3. And then to get rid of 27, I put 27 minus 27 everywhere. Then to get rid of 3, divide everything by 3. So x has between minus 1/3 and minus 9. Minus 1/3, if I'm not sure where we should label it, is almost minus 0.3. See? So x is bounded between these 2 points. Now, this is a situation that you're dealing with fractions, okay? So to get rid of this denominator of 5, I multiply everything by negative. Why? Because in the top also I have negative x, negative 4. But just remember, when you multiply both sides by negative 5, you get a switch inequality sign. Anytime you multiply by negative, you got to do that. So I'll put a minus 5 here, minus 5 here, minus 5 there, right? It's minus 5 and 5 cancel. This become 5, this become negative 5, and sign must be, I'm sorry here. Change the inequality sign. So inequality sign, yeah, inequality sign was less, right? So I change it from less to what? To greater. So I did the change already here, okay? So I did the change already. So x end up having between 9 and minus 9 and 1. Means x is always greater than minus 9, but is less than 1. That's why you see it is between 1 and negative 9. Now we deal with absolute value. There are 3 types of absolute value inequality, okay? And how we solve them. The formula is this. You either have, if absolute value of x is equal to a number, then you change that to 2 equations. X is a or x equal to negative a. Now, if absolute value of x is less than a number, less or equal a number, then if you want to remove the absolute value, you have to put it between a and negative a. Which normally in the problem is the and. What if the absolute value is greater than a number? Then there are two inequalities. One is x greater than a, or it's two pieces. X less than equal to minus a. Okay? So this one is always one piece. It's between a and negative a. This one is two pieces. One is x greater than a, or minus than a. Two pieces, or, because of the or. And this is an and, one piece. See, 1/6 of the number line. All right. So which one is this? X is less. So when you solve the inequality, pay attention to the symbol. Symbol is less, is this. When it's less, then what you have inside of the absolute value must always be between 3 and negative 3. That's what you see here. Okay? If it's less. Well, you want to make sure that this a is always positive. If it's not positive, you cannot do it. Why? Because absolute value is the distance. Distance cannot be negative. Okay? So if what you see on this side is the negative number, that means it's not the absolute value inequality. You cannot solve it, like this problem. Look, it's -1. When you solve this problem, when you find the x, let's say x is 10. When you substitute, you say 10 minus 3 is 7 miles, but you cannot have -1 here. So on the right side, you should always have positive. It's the same thing, no solution. See, you have a -10 on that side. Now, this is a case that absolute value is greater than the number. Greater. When it's greater, is this one, look. When it's greater, then there are two equations. What you have inside of the absolute value is greater than what you have here, or is less than minus that. So see what happened here. So what you have inside of the absolute value is greater than 7, or what you have inside of the absolute is less than minus that number. See, and then these are two inequalities. In either case, when we divide by negative, we got to switch the sign. See how we switch the sign? So remember. So when you solve the absolute value inequality, it has a lot to do with the symbol in the beginning of the problems, what the symbol is indicating. Whether it's greater, like in this case was greater, so it's two equations. Now, when you want to solve the absolute value inequality, make sure absolute value is alone. There is no number next to it. You cannot, see, you cannot use any of this formula if absolute value is not alone. If there is a number sitting next to absolute value, you cannot use the formula until you get rid of that number. Okay? Right here, look. There is a 4 here. So what we do is first we divide both sides by that 4 to have absolute value by itself. Absolute value is greater than the number, right? So when absolute value is greater, you have two equations. One is just what you have instead of absolute value is greater than that. The other one is what you have instead of absolute is less than negative that. This is the second part. It's going to be, okay? Less than negative that. So that's how we write the equations here. Look, two equations. Greater than 9/4, less than minus 9/4. And then the rest is just the algebra. Instead of 8, I write 32/4, so I can take a common denominator. Oh, this is a very simple one. What is the symbol here? Less. Less. If it's less, then what you have within the absolute value, always put it between these two. That's what we do here. If it's less, take it and put it between 16 and negative 16, see? And then I add 7 to all. So x is between 23 and 9. Negative 9 and 23. X is always between these two, bonded between these two numbers. Here, what they're saying is this. They're saying, okay, you see you have that equations. What if the y, which is this, is always between 13 and negative 8? Y is minus 5x plus 17. So they're saying this y, which is minus 5x plus 17, is between these two numbers. So you do that and you solve these equations. Like here they say y is less than 0. When they say y is less than 0, what does that mean? That means minus 5x plus 17 is less than or equal to 0. So these are two separate equations. I mean, one equation with two different scenarios. So this y again means this. Same thing here. Y is less than or equal to 1. That means this, the whole thing is less than or equal to 1. Or y is greater than or equal to 4. That means this. Now here, one thing you need to remember is the radical. When you have a radical and they ask you to find the domain, to find the domain of the radical, what you have under the radical always has to be greater than or equal to 0. Okay? So like if under the radical I have like x minus 3, and let's say this is the equations. Can I just put any number for the x? No. What if you put x equal 1? Does it work? No, because then y is, look at, y is this. 1 minus 3 is radical. What is radical negative 2? Undefined. What if I put 2? No, doesn't work, because then if you put 2 here, then you have radical 2 minus 3 is radical negative 1. Radical negative 1 is undefined. So if you want to put a number here, make sure it's 3 and greater. Does it work if I put 3 here? Yes. Look. If you put 3 minus 3 is 0. What is radical 0? Use your calculator. It's 0. It gives you a number. So when x is 3, y is 0. That's fine. This works. So how do I find domain of any radical? What you have under the radical, take that and set it greater than or equal to 0 and solve this inequality. Okay, that's how it works for those kinds. So what do I have under the radical? X minus 2. That has to be greater than or equal to 0. And this is inequality. Means if you want to put a number here, make sure that number is 2 and greater. If you put 2, 3, 4, 5, any number like that all the way to infinity, you always have a value. But if you take a number less than 2, like 1, if you put it, doesn't work, because then under the radical you have a negative number. So what you do is, what you have under the radical, take that and set it greater than or equal to 0 and solve it. That's how to find domain of a radical. Same thing here. And only works if the radical has an even power. If it's odd numbers, you don't have to worry about that. Just the even. Like, what happens if I have cubic root of x minus 5? Nothing. If it's 3, you could put any number here. Why? Because what if you have a negative number under the radical when the root is on? Nothing. If you use your calculator, cubic root of negative 8, calculator give you a number, negative 2. So domain is domain of radical, when you take the whole thing greater than 0, is just if this number is even number, not the odd. Odd is okay. You could always use your calculator to verify that. Okay. These problems are like very similar to what we did before. And this, you could just tell, this is how to use it in word problems, application of inequality. Okay, so that was the end of section 1.7.